So in this problem, we have a system which is in equilibrium, and your goal is essentially to set up equations that relate all the forces in the figure. So what you should do is at this point pause the video and then set up your equations and then come back and take a look at what the correct answer should be. All right, so assuming that you've done the work now, let's ask some of these questions. If you look at what equilibrium, what we mean by the word equilibrium is that the net force along the x, okay, so summation of all the forces along the x is equal to zero, and so is the summation of all the forces along the y. So in this case, we look at the problem and we see, okay, which are the forces that are pointing along the x direction? Now, if you look at it very clearly, you have F3 and F2 are the only forces that are pointing along the x direction. And clearly from the picture, you notice that they are in opposite directions. Okay, so if we were to set up the summation of forces along the x direction equal to zero, our equation would end up being F3 minus F2 equal to zero. Okay, so if you have this, that's awesome. Let's look at the equations along the y. Now along the y direction, you have F1 and F4 pointing upward, and then you have this W that is pointing downward. Okay, so the equation once again, because the entire system is in equilibrium, would be F1 plus F4 minus W equal to zero. Now, if you had values for, few of the forces, a bunch of the forces, you can figure out whatever unknown quantities that might be in the problem. The important thing here is to recognize how to set up these equations once you have forces simply along the x or the y direction. Now, in the next video, we'll take a situation where we will have to use vectors and break the forces into components and then set them, set the x forces equal to zero and also set the y forces equal to zero. But this picture should help you with future systems and just in making sure that you equate all the x forces equal to zero and I set up all the y forces equal to zero.